Hi everyone, it's me, Luciana, and today I want to talk about the amplitude modulation. So, what exactly is amplitude modulation? Amplitude modulation, or AM, is a process in which the amplitude of the carrier wave is varied in proportion to a modulating signal, such as the audio or video signal. These techniques allow the information or data to be transmitted over a radio carrier wave. There are numerous applications of these amplitude modulations. For instance, the use of the radio waves can be made for transmitting data and information in amplitude modulations. Also, it's used by the Navy dispatch and police radio systems. Other than that, it's also used in two-way communication radio systems, modems of the computer and citizen bank radio, and of course the aircraft communication. In amplitude modulation, a carrier signal with a frequency much higher than the modulating signal is used. This modulating signal, or also referred to as message signal, contains the information we want to transmit. When the carrier signal is modulated by the modulating signal, a new modulated signal is produced. This modulated signal can then be transmitted to convey the desired information. Now, let's talk about the amplitude demodulation. Amplitude demodulation is a process of extracting the information from the modulated carrier wave. Essentially, it retrieves the original modulating signal to access the transmitted audio, video, or other types of data.
Hi, my name is Isaac Nakudin, and today I will discuss about angle modulation. Angle modulation is a type of modulation in which the angle of the carrier signal is varied according to the instantaneous amplitude of the modulating signal. Unlike amplitude modulation, which the amplitude of the carrier wave changes, angle modulation keeps the amplitude carrier constant and varied at its frequency or phase. As mentioned earlier, there are two types of angle modulation, which is phase modulation and frequency modulation. In phase modulation, the phase of the carrier signal is directly proportional to the amplitude of the modulating signal. This approach often used in digital communication systems such as phase shift keying. And in frequency modulation, the frequency of the carrier signal varies with the amplitude of the modulating signal. This makes the frequency modulation resilient to the amplitude noise and suitable for high-quality audio such as FM radio broadcasting and satellite communication. Now let's talk about the relationship between phase modulation and frequency modulation. In modulation, phase modulation can be used to generate frequency modulation by integrating the modulating signal before applying it to the phase modulator. Similarly, frequency modulation can also be used to generate phase modulation by differentiating the modulating signal before applying it to the frequency modulator. For demodulation, phase modulation and frequency modulation signals can often be demodulated by using similar principles. For an example, and frequency modulation signals can be converted into phase modulation signals by passing it through the frequency to phase converter. This interchangeability is key to designing the flexible communication system.
Next is digital modulation. Digital modulation is the process of encoding a digital information signal into the amplitude, phase, or frequency of the transmitted signal. So there are four types of digital modulation. The first one is amplitude shift keying, also known as an on-off keying and interrupted continuous wave. It represents binary value with two amplitudes, where the bit 1 represents maximum amplitude of the carrier and bit 0 represents the amplitude of 0. So there are two methods to generate amplitude shift keying. The first one is by using the multiplier. So the multiplier are intended to multiply the signals that come through from the low pass filter. Next is by using the switch. So the value 1 will make the switch open and the value 0 will make the switch close. So this method also implement band pass filter to limit the bandwidth signal from the information signal. So there are two methods to recover the original signals. So the first one is by using the envelope detector, where the signals will pass through the half-wave rectifier, which are functioned to allow the signal from the positive part to pass through and filter out by the low pass filter. And next is by using the coherent detector. So the coherent detector used an oscillator to set the carrier wave frequency to obtain the original signal. So the output from both of the method is binary signals, which is 1 and 0. For the second type of modulation, it is a frequency shift keying. So, the frequency of the carrier signal varies according to the digital signal changes. So basically, it is a two baseband of ASK produced and combined to produce an FSK modulated wave. To generate FSK modulated wave, first we will use the multiplier, where a signals will come through an inverter and pass through the two modulators and will be summed at the summing amplifier to produce an FSK modulated wave. So if there are bit 1, it will mark the output frequency, and if it's 0, it will mark an output space frequency. Next is by using the voltage control oscillator. So there are a switch between the two values to ensure that when the FSK signal moves between the mark and the space value, there won't be any phase or amplitude discontinuities. To obtain the original signal, we will use an asynchronous detector, where the output from the filter will determine whether logic 1 or 0 is generated by the logic operator. So basically, the filter will tune two different frequencies which are at omega c plus delta W and omega c minus delta W. Next is by using synchronous detector, where one multiplier will receive the locally regenerated mark frequency as its second input, while the other multiplier will receive the locally generated space frequency to produce an original signal. So the third type of modulation is phase shift keying, where the carrier signal phase changes from 0 to 180 or from negative 90 degree to plus 90 degree depending on the digital signal. So it is also called as a phase reversal keying, and for zero binary input, we will see here that the phase will be 0, and for the high input, the phase will reverse back to 180. To generate PSK modulated signals, we will use multiplier, but the key element here is by using level converter to convert the digital signals from unipolar to bipolar format. We then will use the balance modulator to act as a phase reverse switch, where the carrier phase output will shift between two separate angle about 180 degree. To generate information signals back, we will use multiplier and low pass filter. So the fourth type of modulation is the quadrature phase shift keying, where the information signals is used to modulate two separate carrier waves out of phase with each other exactly at 90 degrees. So a constellation diagram is used as a representation of a signal modulated by the digital modulation scheme. So this is the constellation diagram, where we can see here that the QPSK phase changes from these angles.
Hello everyone, my name is Nur Afika. Today I'm going to discuss recent advancement in communication field, which is artificial intelligence (AI) in communication. First of all, what is AI? AI in communication refers to the use of AI-powered tools and technologies to enhance how humans exchange information. It combines machine learning, natural language processing, and automation to improve accuracy, efficiency, and accessibility in interaction. Now, let's move on to the impact and benefit of AI to the society. First, improve learning and communication. AI-driven tools support collaborative environment in remote work and education, making communication more interactive. For example, students use Zoom apps to online meet and communicate easily. Second, breaking language barrier. AI-powered translation allow global communication by allowing collaboration across cultures and languages. And third one is improve business efficiency. Routine communication tasks can be automated to reduce workloads and allow for a greater focus on strategic projects. Next, what is misconception of AI? First, we have health issue. Dependence too much on AI-based communication technologies causes tension and conceptual weakness. Second, legal issues. AI-driven communication goes against privacy and copyright regulation. And the last one is safety issues. Communication using AI, particularly fake information technology, risks privacy and security. These are solutions to misconception before. For health issue, improve knowledge of technology and appropriate AI use, and also perform ergonomic studies to protect users' mental well-being when working with AI products. Then, for legal issues, support for globally recognized AI policy and encourage ethical AI practices, including permission to data collection. And the last one, for safety issues, create AI transparency standard to help users understand how decisions are made, and support cybersecurity advancement to safeguard confidential communication.